Hi, here I have a lesson on solving systems of equations by graphing. So we're going to take a look at two linear equations and we're going to find the solution to those two linear equations by graphing. But before we get to that, I just want to have a quick review on graphing lines. And I have four examples here. We can see two of them. I'll get to the other two in just a little bit. But I have this y equals negative x plus 3. And I like it in this form. It's in slope-intercept form, which allows me to very quickly identify my slope, which is right here, remember, in front of the x. That's that negative sign, which really represents -1. That's my slope. And I can also see my y-intercept very quickly. It's right there. It's 3. So when I come over to my graph, I go up 3. 1, 2, 3. There's my y-intercept. It's where it crosses the y-axis. My slope is -1, which tells me I'm going to rise 1 and run 1 to the left. Rise 1, 1 to the left. Rise 1, 1 to the left. So on and so forth. And I like to put in all of those points so that when I get my straight edge out, I can make the best line for my graph. Got them all in. Get my line tool. I make it, and then I like to keep it color coordinated. So I'm going to turn it to blue. Put the arrows on it because we do have a line. I want to represent that it keeps going forever and ever, both left and right, up and down. Now my second one, the x plus 3y equal to 3, this one's not in slope-intercept form, and I don't like it this way because I can't identify my slope and my y-intercept, which makes it pretty easy for me to graph the line. So I'm going to put it in slope-intercept form, get the y all by itself, so I got to get rid of the x. Now I'll end up with 3y equal to negative x plus 3. Divide both sides to get that y all by itself, and now I'm left with y equal to, I could write it as negative x over 3, but I like to see that slope a little bit better, so I'm going to write it as negative 1/3 x, and then 3 divided by 3 is 1. Now I can see my slope is right here, the negative 1/3, and my y-intercept is 1. And now I can graph that. So I start with the y-intercept that's 1. I have a slope of negative 1/3. So this time I'm going to rise 1 and run 3 to the left. Up 1, left 3, up 1, left 3. Or I could go down 1 and right 3. Down 1, right 3, down 1, right 3. Until I get to the edge of my graph, get my straight edge out, and do the same thing. Make my line. Just got to put my arrows on it and keep it the same color, and we're good to go. Now, the two that you didn't see, they're down here. And again, the green one now is not in slope-intercept form. So I'm going to get it into slope-intercept form by subtracting 2x from both sides. And now I have 2y equal to negative 2x plus 6. Divide both sides by 2 to get that y all by itself. And we have y equal to negative x plus 3. Again, my slope is the coefficient of x, which is negative 1 in this case, and my y-intercept here is 3. Come up here, y-intercept is 3, up 1, left 1, up 1, left 1, or down 1, right 1. And I'm noticing that I have the same as that blue one, so I'm not going to put all the points in there because I already have them. I will put my line in there though, just like so. See if I can get that one highlighted so I can turn it green. It's green, make it a line. And there we go. So really that's two lines on top of each other. It's the same line. It's not any different. And then last but not least, I have this purple one that I have to get into slope-intercept form very quickly just by subtracting x from both sides. That gets our y all by itself. And there we go. Just need to identify our slope. Remember, coefficient of x. Oops, we don't want it that color though. Let's try that again. Our slope is right here. Now our y-intercept exists right here, but since it's not written, we know that it's a 0. So then I come up here, y-intercept is 0. My slope was negative 1, so I'm going to go up 1 and left 1. Continue this pattern until I get all the way to the edge, and then I'm going to come down here and I could go down 1 and right 1 all the way to the edge of my graph, and then put it in, my straight edge. Please use a straight edge. Don't try to do this by hand. It just does not look as good. Now, the one thing that I wanted to talk about is the reason that we make these lines is to represent all of the solutions to our equations. For example, I come back to this blue equation that we started with, y equals negative x plus 3. There are infinitely many solutions. Now, one of those solutions was the y-intercept, 0, 3. The reason it is because if I put 0 in for x and I put in 3 in for y, it makes the equation true. I look at the right side right now. Well, the right side would equal 3, and the left side equals 3. 3 equals 3. That's why it's a solution, because both sides are equal to each other. You know, if I picked another point like this one right here at negative 1, 4, and I were to put that into my equation, put the negative 1 in for x, put the 4 in for y. Now when you look at the right side of the equation, I have a negative 1, which would be a positive 1, plus 3 is 4. Well, the right side is 4. 4 equals 4. That's why that's a solution, and that's why that point is on the line. So the line is made up of all kinds of solutions, which brings me to our next slide, which is where we're going to solve a system of equations by graphing. Now, a system of equations is nothing more than having two equations, and we want to find that solution to that system, meaning I want to find a solution that works in the blue equation, and I want to find a solution that works in the red equation at the same time. So in other words, it has to be the same numbers. Now, when we do that by graphing, we're going to look at the blue line and the red line. And remember, every single point on the red line is a solution. Every single point on the blue line is a solution. So then, when we go through this, all we have to do is look for where do those lines cross. Well, they're crossing right here. And where is that? Well, that's at the point 3, 0. So my x value is 3 there. My y value is 0. That makes the blue equation true. It makes the red equation true. Therefore, x equals 3, y equals 0 is the solution to that system. Now, sometimes you're going to see that written in point format like this. So it just depends on how the question is asked and which answer it wants displayed, but either one would be acceptable here. Now, my second example, I have the system of x plus y equals 0 and 2x plus 2y equals 6. I have it color coordinated, so it makes it a little easier here. We look at the purple line and we look at the green line, and we ask ourselves, well, where is a solution that works in both of them? Well, when I look at these, they're never crossing. So they're never going to have a point that makes both of them true, because they're parallel. And when we get a situation like this, we say that there is no solution. I don't know why I did that. I'm trying to use this pink color. Let's try that again. No solution to that system of equations. Now I go down to my next one. I'm going to look at the green line and the blue line. Now the green line and the blue line, remember, that was the situation where we had the two lines on top of each other. Well, that tells me that if I look at a point on the blue line, it's a solution to the blue, but it's also a solution to the green. And if I pick a different point on the blue, it's still a solution to the blue and the green. So it doesn't matter where I look on this one. Every single point on the blue line is a solution to the green line and vice versa. Therefore, there are infinitely many solutions, and that's what we're going to write. We're not going to write down any of those solutions because it would take us forever to write them all. We're just going to write down infinitely many solutions. That's the case where we have a line on top of a line. And last but not least, we have the red and the purple. We've got to look at where do the red and the purple intersect. Well, those two lines are intersecting right here, which when I look at that, that is at negative 1/2, positive 1/2. And when I say that, I mean that x is negative 1.5 or negative 1.5, and y is positive 1.5. Or the way I said at the start, I said it more of a point format, negative 1.5 comma 1.5, and there's your solution. Now, the last thing that I want to talk about is just the review of everything we did. So when we're going to solve a system of equations by graphing, we want to identify that x and that y that make both of the equations true. Well, what could happen when we're looking at that? So if you think back to that previous slide, there were three things that happened. One, the lines intersected at one point, meaning there was one solution. Now, little vocab on that, it says the system is independent if that's the scenario. If they intersect at one point, we get one solution and we say that our system is independent. Now, the second scenario could be that our lines are the same line. That was the one with the blue and the green. And when there was lines that were the same line, we have infinitely many solutions, and we say the system is dependent. And then we had our last example where the lines did not cross, they were parallel, and if those lines are parallel, there are no solutions that make both equations true. And then I just drew a picture of what I have here. So if they intersect at one point, we get that picture that could look like that. If they're the same line on top of each other, and then our last situation where we have the parallel lines. And that's going to conclude my lesson on solving systems of equations by graphing.